Hi Siva.
Yeah, hi sir.
So what are you doing today?
So today I'm going to with the AWS EKS topic. Just deploy the simple web page app by using AWS EKS. So this is our today demo. Okay.
Okay.
So basically, this is the introduction about AWS EKS. So Amazon EKS is basically Elastic Kubernetes service, which is managed service by AWS. So that allows you to run Kubernetes on the AWS cloud without having to set up and maintain our control as well as the nodes cluster. So it will be managed by the AWS only. So you can just configure your first things. So to achieve the high availability with the EKS and run the Kubernetes control plane across the different availability zones in our AWS cloud. So we can integrate the EKS with the other services as well to provision the various facilities to access the other features also. So for example, like you can connect with worker nodes with by AWS EC2 instances. So this is our EKS introduction. So for the deploying some sample web page, first of all, we need to create the EKS cluster in the AWS. Then we will create one pod in the cluster, and we can follow with the pod, and we can create a deployment with the cluster in the cluster, and we need to create one service to access the deployment. For that, I need to create one node port service in the cluster, so we can access the web page by using the public IP of this service. Then we need to create one load balancer because the node port service is basically for internal testing purpose. So, but for the end user to connect with any problems or failures, so we can create one load balancer service, and we can attach to the our deployment. So we can access the web page by using the DNS URL of the load balancer. So these are the tasks I'm going to do now. So first I need to create EKS cluster. So for that, this is the task one, EKS cluster. So first of all, I need to launch one EC2 instance with the T2 micro configuration. Okay, so let's go to our AWS console. So this is my AWS console with my user IAM user. So go to EC2. Okay, let's change my. I think I will go to Mumbai AC. Okay, go to EC2. Click on instances. Launch instance. So I'll take the name EKS only. So come down, select Ubuntu OS and select 20.04 version. This is T2 micro only. Select key pair which I have created earlier. So I'll go with default options, VPC as well as the public availability zone. So public IP is enabled. Uh, just allow HTTP service. Go with 10 storage. So create launch instance. Click on instances. So our server is launching. So this is the first step. We need to create EKS cluster. So next we can configure the AWS ELI in the EC2 server by using the following commands. After that, we need to install kubectl as well. So for that, these are the commands. Next, I need to install EKSCTL to configure the cluster EC2 server. So for that, these are the commands. Then we can create a cluster with the following commands in the AWS. we need to assign the IAM also with the OEDC provider to form the cluster in the AWS. For that, these are the commands. So at last, we need to create a node group with adds on in public subnets. So these are the parameters which I have given, a region as well as, wait, I will increase this. Yeah, cluster name is this one, and the region and the name of the cluster, and the node type is sticky medium. How many nodes we need to create? So this is the minimum nodes, this is the maximum nodes, and the volume size is 20. This is the we can access with the SSH port with the 22, and the public key also we need to mention here. So these are the following parameters I have given. So let's go to our AWS console. Okay. So now our server is running. Okay, let's connect with Mobaxtem. Okay, click on session. Go to SSH. Okay, remote host. I need to mention the public IP. Copy this. Mention that this is Ubuntu server. So just mention Ubuntu. Click on SSH. Use private key. So select Mumbai region. Mumbai key. Click on OK. So our server is now ready to install EKS cluster. So for that I need to follow the steps before I have created it. So next, yeah, first of all we need to update that thing. Sudo apt get update. Okay. Let's type sudo apt update. So next I need to configure install AWS CLI and also configure in the local. So for that this is the command sudo apt get install AWS CLI -y. Install CLI -y. So after the installation of AWS CLI, we need to configure with AWS configure. So it is installing AWS. Okay. Now we can configure with AWS configure. So we need to give the access key as well as secret key. So having my local. Okay. So you need to mention your access key as well as secret key. So enter default options. Okay. Enter, just enter. So we have configured the AWS CLI in our server EC2. So now I need to install kubectl. So these are the commands. First I need to execute this command. or otherwise I can go to the internet. So install. So I can install from this official website. Let's go to down. So this is for Linux. You can go through with Mac OS as well as Windows as per your convenience. So let's install our okay. This I will take a 1.222. I will take a curl command first. So next I need to take in the SSH 256 for the same version. Step. So next I need to check the paste, open SSH with the kubectl. Next I need to execute the permission for the kubectl. So let us execute that permission also. So next I need to create one directory with under a home directory with the bin. So we can copy this kubectl under the to the home directory. So finally we need to verify the kubectl version. Just export with this command also. So let me verify the kubectl version in our EC2 server. So this is 222.6 AKS version. So after that, so these are the commands I have executed for the kubectl installation. So these are the commands. Okay, let me go to ekctl. So we need to install ekctl as well in our EC2. So for that, these are the commands. So I can go to type okay, this is the official website. Click on it. Okay, these are the commands for Linux. So curl command. Next I can move the directory temp ekctl to under local bin folder. So just verify the version. So this is 0.115.0 version ekctl. So we have installed AWS CLI as well as kubectl, and the third one is ekctl in our EC2 server. So let's go to another steps. So now we have ready to create the cluster in our AWS. So for that, these are the commands. ekctl create cluster. So I'll take this. Okay, just go to, I'll create the with the cluster name is test, and I'll go with the region AP. So I think I'm in so Mumbai region, AP South 1. So for that I need to mention AP South 1. So this I need to change the zones also, AP, A, and 1B. So I'll just go with the without node group first of all. So let's create EKS cluster with these comments. So our EKS CTL version is, and our region is AP South 1, as well as subnets in South 1A and South 1B. So this is the Kubernetes version 1.23, and our cluster name with the test in South AP South 1 is region with now it is creating in the AWS in the backend. So I think it's take a few minutes. So meanwhile I will go with another steps in the slides. So after installation of cluster, so let's create and associate the IAM with the OIDC provider, and we can create the node group with that. So without we can access the IAM with the OIDC provider, we can't able to access this node group. So for that I need to mention here. After that we can just check with the kubectl get nodes, so we can verify with the command, this command, once cluster is created. So after we have created, let me create a pod also. For that I have just introduction to about the pod. So basically the pod is the fundamental building block in our Kubernetes. So it's a great way to logically group multiple containers into a common deployment. So we can configure the single as well as the multiple containers within the pod. And the pods basically it is encapsulate all of the configuration needed to run the application. So it is very lightweight. So basically the pods are and the containers are very slightly different, but not both are same. So it's nothing but more than it's a box in which the container applications are being inside the pod. So these pods are being deployed on the Kubernetes nodes, so we can access the nodes from the pods. Let me show. Still the cluster is creating. Okay, let me go to the pod. So this is the I'm going to create a pod with a simple. So this is the code I have taken from the kubernetes.io official. So basically I need to mention the version of the container with the API version is V1. You can type as per your requirement. And the kind is the pod. So since I have creating the pod, so that kind is name is pod. And I need to mention the details of that pod. So for that I have taken the metadata. So under the metadata, so the name of the pod is static web, and we need to mention the labels. So labels are the very important key factor in our pod as well as the deployment purposes. So we need to mention the labels also, and I have taken the role is my role, and I need to mention the specifications for that pod, so that I have taken the so these specific container details is needed to create the pod. So for that these are the details I need to mention in the specification, under the specification. So the container, so basically the name is I have taken the web name with the container name, and I need to mention the image. For that I have taken the nginx from the dockerhub.com. So it's officially from the official dockerhub.com I have taken the image name, and I need to assign the port numbers with this port. So for that I need to mention the port as well. So for that I have taken the name is web, and the container port we can access the port number with 80, and this is protocol TCP protocol we can access from the TCP. So this is the simple pod I have created. So actually this code is available in our kubernetes.io, so we can modify with our requirement as like that. Since the cluster is creating, okay, let me take. So this is about pod, and these are the commands we can create the pod with these commands. kubectl apply -f pod.yaml, and we can verify with the pods with this command kubectl get pods. So after cluster is created, I will create a pod, and I need to mention as the deployment purpose also. So this is the introduction about deployment, how deployment happens in our Kubernetes and EKS cluster. So the deployment in Kubernetes, it is a is a Kubernetes object, so which can run multiple replicas of your application as well as in instances that automatically replace any instances that fail. So the replicas is one of the key factor we need to mention in our deployment YAML file. So because the replicas is nothing but how many pods containers you need to run in the pod itself. So you need to mention the replicas. So for that, so we can use the deployment easily to upgrade the pod instances using the rolling update and the rolling down. We can easily do the changes, and we can deploy multiple instances of our applications for our end users with the help of deployments by using the replicas. So we can scale up or scale down as per our requirement deployed applications depending on the user load which we are facing on the cluster. So using YAML files, basically we can create a deployments files for the web page applications. So this is the YAML file I have created with deployment. So the API version is apps/v1. You can take as per version, and the kind is deployment. Basically, as before I said, so it's a kind before we created pod, right? So the kind now the kind is deployment, and we need to mention the metadata. So under the metadata, I have taken the name Nginx, and we need to mention the labels because suppose if we have 100 containers to run the application, so we need to mention the labels under which container you need to deploy for the particular task. So for that I need to mention the labels, and I need to run the Nginx app under the labels. So it will particular containers, it will deploy in the particular containers itself. So I need to mention the specification. So under that I need 5 pods replicas of, to maintain and to deploy. So for that I need to mention replicas, and the selector is you need to this is one of the key factor while writing in the ML files. So you need to mention selector because on the match labels you can identify the which pods you need to deploy. So for that you need to mention selector. So you can select how many containers you need to deploy with this YAML file which you have configured itself. So for that I need to mention the selector. So you need to mention in the labels under the match labels, and I need to run the Nginx app. So this under the labels, this Nginx and this Nginx should be the same name. So otherwise it won't run. So based on the template, it should create the replicas with in our pod. So you need to mention template. So it will create based on the template, like it's an Amazon machine image in our AWS, right? So for that I need to mention the metadata same as well, and the labels. So the labels are same Nginx app and run in Nginx app. So for that the specification is I need to take the container with the name Nginx container, and the image name is Nginx. with 1.7.0 will access with the port number 80. So this Nginx app and Nginx app, so these three things should be the same name. So otherwise you can't create the replicas and with the deployment file which you have configuring. Okay, still our cluster is running. So it is still creating in the AWS cloud. So this is our deployment YAML file. These are the commands after to deploy the YAML file with the different containers. So next I am creating one service because just I have created a deployment file. So far I need to access the deployment YAML file. So for that I need to create one service. So I have taken the service node port service basically. So by default the Kubernetes has the cluster IP service. So here I am using the node port service. So for node port service I can access the deployment YAML file with the node port service. So services basically it is a way to expose an application which is running on a set of pods on the network service itself. So these are the different services like node port service, cluster IP, and load balancer as well. So node port service it is a service we can access with each node port IPs. In simple terms, we can say that this service helps to expose the services or applications which is running on the pods to the end user. So basically, the another service is cluster IP, so which is a only accessible from within the cluster itself, but we can't access from the outside. So this service helps the pods to access the services which is running on the other pods as well. So this basically it is inter pods communication service, and I'm going with another load balancer. So since because why I go with the load balancer service means you can test this node port service is basically working on the internal purpose only, but the end users can access the web application without any failures or crashes inside the container. So for that I need to create one load balancer with the DNS, so they can access the end users with the DNS name of the URL. So that DNS name is it couldn't change because it is the static only. So this service with yeah, you can say that this service helps to load balance the user request for the applications which is running on the pods via the load balancer URL. So these are the basically services which we can access the application web page. So still our cluster is creating, waiting for cloud formation. Okay. So this is the basically node port service YAML file. In that the IP version is same v1 and the kind name is service. Since I'm creating the node port service, so the kind is service. So we need to mention the metadata of the details for that service. The name is my service, and we need to mention labels. And I have taken the Nginx app, and we need to mention the specifications. And the selected is same Nginx app, and the type this is the node port type. Uh, we need to mention the ports with we need can access from the internal purpose. So for that, I need to mention the node port is this one. As think the node port ranges from the 30,000 to 32,000. So you can take any number in between that one. And the port with container is 80. The target port is 80. So this is basically our node port service YAML file. which I have taken from the Kubernetes.io official website. So these are the commands which we can create the service and pods. Okay, so our EKS cluster test in AP South 1 region is ready. Okay, so let me verify in the console. Okay, let me increase the size. So go to EKS, search for EKS. So our cluster, yeah, it is in active state. Okay, so now I need to execute the remaining things. Yeah, so I created cluster, and now I need to give the access to the IAM with YDC provider. So for that I need to let me take this. So the region is AP South 1, AP South 1, and that cluster name is test. Let me approve with these comments. Enter. So we'll create IAM OpenID to connect to the provider for the cluster test in the region. So now it has access there with the provider. Now I need to execute I need to create a node group with additional parameters. So for that, this is the EKS create a node group, cluster name as well as region, and the name of the cluster name, EKS demo, node port type is T3 medium. So these are the comments. So I have written in my notepad. So the cluster name is test, and this take this out one. Case demo, that's case demo T3 medium, and I need to mention the key. So this is the Mumbai region. I just created Mumbai key. So everything is safe. Let's do. So it's good here. Enter. So it is creating in the console. Okay. So the node group is creating now with the two clusters. So it is taking a little bit time. So I have discussed pod also and deployment also. Service, yeah, we discussed this one also. So after we created the service, we can access the web page by using public IP. At last, we can create a load balancer service so that end users can access without any yeah, failures are in the web application. So for that, I need to create a load balancer service. So the API version is V1 and the kind is service only. So I need to mention metadata as well. I mean, I have just entered the my service name with the labels Nginx app with, and I need to mention the specifications. On the specifications, I need to mention the selector. So based on this selector, it will create a load balancer. The type is load balancer service, and we can access with port number 31,000. So we can just mention the port number under in between 30,000 to 32,000 on that range. So the port container port you can access with 80. The target port is 80. Should be same container, so that end users can access without any uh, failures on the code. If anything happens, then EKS will take care of it. But end users can access the web page at any time with the load balancer service. So it is taking time. Okay, so all node groups have up to date with the templates. Okay, let me verify the console. Okay, let me refresh once again. Okay, our test case nodes are created in the console itself. So now I need to create pod, right? Basically. So which I have explained this, right? So let's take the pod. Where is pod? Yeah. So here I have taken the pod ML file. So because you need to maintain the indentation, that one. So for that I have taken the notepad. So let's take this one. Create. Okay, so pod.ml. Click on I insert. You need to mention this. So API version and the kind is pod and metadata. So the name is static web, and you need to mention labels. Under label, role is my role, and the specifications. So in that specifications, the container name details which are required to create a pod, right? So for that mention containers. The name is image name is Nginx with the name web, and the ports container port 80. The protocol TCP protocol we can access. Escape. Hold on. WQ to save this file. So let's enter sudo apply pod.ml. So this is the command to create pod. Enter. Okay. Command not found. kubectl. Oh, sorry, need to mention kubectl. Confused with the sudo command. Subsidy apply open a pod.yaml, the name of the pod, right? So our pod is created. So let's go to kubectl get pods. So our pod is ready with the static web name, and it is status running state. So it has created 18 seconds ago. You can delete the pod also with this command kubectl delete pod and the name of the pod. Okay, let me execute that command kubectl delete pod, and the name of the command is static web. Enter. So pod static web deleted. So let me verify whether it is deleted with kubectl get pods. So no result, right? So deleted successfully. So this is about pod creation and deleted. We can because in organizations we need to create deployments. Main purpose for that taken with the deployment ML file. Okay, let me create the deployment ML file. Sudo vi deploy.yaml. Click on insert. So this is the deployment YAML file. So as we discussed earlier, the API version is v1 and kind is deployment. So you need to mention the metadata. So the name is Nginx, and the labels, you need to mention the labels under the metadata. So this is the Nginx app specifications, and we need you can give the replicas as per your desired required environment. So you need to select and the match labels. Under the match labels, and I need to mention the Nginx app. So based on the template, it will create the containers with these replicas. The run same Nginx, and you need to mention the specification. These are the details which we need to require to create the pod also. So for that containers, the name is Nginx container. So image is Nginx. So it's taken from the Docker Hub. The container pod can access with 80. So this should be same the Nginx app under the labels. Okay, save this one. Okay. So let me create deployment YAML file kubectl apply. Open it. Deploy .yaml. So our Nginx created deployment. So let me verify kubectl get deploy. So we have mentioned 5 replicas, so that it is up to date with the 5 replicas. Let me go to kubectl get pods -o wide to see the how many pods are created. kubectl get pods -o wide enter. So our 5 pods are running on the basis of node 219, 192, 168, 44, 219. 219 and another one is 179. So this I think a 5-way type is. Let me verify the nodes. So this is 179, 28179. 28179 and another one is 44219. Let me take this one 44219. Yeah, this is private IP address. So it is running on the pods on the servers, both servers. So now I just created a deployment YAML file. So in order to access this deployment file, I need to create one service to access the deployment. So for that I need to create a service also. Sudo svc service.yaml. So basically it is for internal testing purpose. We can access with service file. So for that this is the code I have taken from the Kubernetes official website. Let me take. So the API version is same and the kind is service. So you need to mention the metadata in the labels and the selector also. So it should be same the Nginx app and Nginx app, and the type is node port, right? So now I'm creating the node port service. So just I mentioned the node port, and I can access with the public IP of the colon 31111 port number. So let me execute this. So go public queue to save this file. So let me create with the kubectl apply -f is service.yaml, right? So to create service, enter. So our service is created. So kubectl to verify get service, enter. So our node port service is created with container port colon 31111 TCP. So by default the cluster IP is available. Okay, let me verify with kubectl commands. Get pods. Okay, kubectl pods to view the pods. So our 5 pods are running. Okay, let me verify with this your port number or the public IP. Okay, you can take as any one. Okay, I'll take with 1111, right? Enter. So we can test with the internal purpose with the node port service. So whether it is working or any problem it has. Okay, this site can't be reached. Okay, let me open the ports. I think you can. Okay, you can open the ports as well. Security group issues. SSH HTTP. Okay, let me edit inbound rules. Okay, for the I'll go with all TCP for the demo, but you need to mention the required port only. And you check the outbound rules. Okay, all traffic, fine. And you need to mention in the test case. Okay, let me change the security group to access the web page. all traffic still some way. Okay, let me. Yeah, still it is somewhere. Okay, let me edit here also. Then display with anyway. Okay. Once again. Okay. Okay. So the port issue we are facing. Okay. So now it is able to access the web page.
Good, very good. You share you URL to me also. I'll also test from here.
Yes. Fine.
So finally it reached to Nginx website.
Yeah. And we can also verify with other instance. Okay, let me verify that one also.
Direct IP address of EC2.
Yes, yes. Another easy to another instance also is there. Let me verify with that one also. Double one, right? Yeah. So both servers are accessing the web page.
Yeah, one is DNS of ELB and another one is your pod IP, right?
No, no. Still, have created just service node port service. Now I will go to create load balancer service. Uh, then we can able to, because with the node port service, basically you can test in the internal purpose. But if anything happens inside the pod or anything fails, then the end user cannot able to access the web page, right? So for that I need to create a load balancer, and now I will go to create a load balancer service.
Okay.
So in order to create load balancer service, first we need to delete this service, because now it is accessing, right? So first we need to delete this service. For that, okay,
Okay. Go
ctl
ahead.
delete service. Okay, service, and the name of the service. Yeah, okay, node port, right? The name of the service is my service. Let me execute my service. Now, okay, service, my service deleted. Okay, now we can create a load balancer service. Okay, sudo, I'll take just lb.yaml. Let me take this load balancer YAML file. Sorry. Okay, let me insert. Now the service is same, but here I need to mention the type load balancer. So previously I mentioned the type is node port, right? So everything is same. Now I can access with node port. I just mentioned the 31,000. So you can mention as per your wish, with under in between the 30,000 to 32,000 range, and everything same. Just mention the node port type is load balancer. So let's save this file with wq. Okay, let's create a load balancer with the apply -f lb.yaml, right? So yeah, our service is created, same name with same name. So let's verify kubectl get pods. Okay, let me verify in the console whether load balancer created or not. Let me go to load balancers. Yeah. So created, right? At 9:23 a.m. So this is our load balancer created with service. So yeah, this is the DNS name. Okay, we can verify with the DNS name. So let me go to instances whether it is in, okay, it is in service only, so we can access from the DNS name. This is the DNS name of load balancer. Let me enter. Yeah, it is showing, right? Okay, I'll keep it in the cell phone so that you can access. So let
Can you copy that to me?
yes.
I'll also test.
So that is the DNS name of the load balancer.
Yeah, ELB DNS, right?
Yes.
This is a long name actually.
Can verify TCP HTTP check.
Yes, it is working. Good. So one is what are the URLs you tried it? Can you explain one more time? One
Yeah,
is
yeah, fine.
ELB and
So
other things are what?
one is basically we create a deployment, right? So deployment YAML. So we need to access that deployment YAML. So for that, I created one service with Node port. So basically, it is a good for internal testing purpose whether the web page is accessing correctly, properly or not. So once it is verified with Node port service, so why we can go to load balancer service means basically if anything happens inside the pod or inside container, if anything crashes or any failures, human errors, so if anything happens, then the end use customer couldn't able to access the web page with the node port service, right? So basically this is like public IP dot some the node port number. But if we can create load balancer, so the person we can access with the same URL, DNS name of the load balancer. So it couldn't change, right? So it is static only. So if anything happens backend, like in the pod or any container crashes, so another container will replace within fraction of seconds. Then
So auto scale feature is implemented in hidden.
yes. So this
Within that.
URL is, yeah, this URL is static, right? So you can access the web page at any time.
Okay. And later they can assign to public IP also the DNS.
Yes.
So website name can be given.
Domain,
And,
yeah, domain.
yes, domain name. Yes. Okay. Good. Now I'll stop recording.